Hi guys, this is Caleb back here on YouTube from All Around Welding LLC, but I'm not All Around Welding LLC anymore. I haven't yet to figure out a good channel name, so it's just going to go undetermined for now, but I thought that I'd go and do something a little bit different than what you would usually see on a welding channel. Today I'm going to be reacting to a video, a welding OSHA 30 safety video. And before you ask, no, I'm not going to add some funny commentary into it. I'm just going to go ahead and just elaborate on what they're talking about in the video. Now, unfortunately, I can't show you any clips from the video, but I'll leave a link down in the description below if you want to watch. You will, however, get audio just because I'm going to be reacting to it and giving my take on what's going on. So, without further ado, let's go ahead and get started.
Every day, welders in various industries use high temperatures to shape metal. Sometimes the metal is bonded together, other times it's cut apart. Over the years, engineers have developed a variety of methods for welding. The combination of a spark, oxygen, and a flammable gas provide the energy for oxy-fuel cutting, welding, and brazing.
So, back in the day, like the 1800s, the only thing they had was like forging, which was like you have to heat up a metal under a flame, and then you had to bang it out with a hammer. Whenever acetylene was discovered and invented by Sir Edmund Davy, back in, I think, 1835, 1836, that's whenever oxyacetylene was really, picked up. It's still used in industry today. I mean, I learned oxyacetylene first thing in the shop in 10th grade. And I'm a college freshman now. So, if that gives you any indication on how historically prevalent oxygen and acetylene are as a mixture, then yeah. Let's continue.
High voltage electricity, whether it's alone or used in tandem with various gases, powers arc welding.
So I first learned arc welding back in the 10th grade. It was 2017 whenever I first learned arc welding, and like it was stick. So like you have a flux covered electrode, and you have your stick lead. You plug it into the stick lead. You plug your grounding clamp onto the table, which is called a workpiece in industry, and then you weld. That was what I first learned whenever I was first learning welding. That and oxygen acetylene cutting. Never really learned how to oxyacetylene weld until my junior year in technical school. Now, I've done a little bit of MIG and a little bit of TIG, but we're not going to elaborate on that more in this video. I'm just going to give you a general briefing on what I've learned over the years.
The first thing to do is to inspect your equipment. When you're working with an oxy-fuel unit, make sure your torch has the right tip for the job at hand.
That is very important. Do not use a tip that's not rated for the job that you're doing. It's a common mistake, and it's not something you should be playing around with. If that happens, you can go and have something, you can have a sustained flashback, and it's not good.
Examine the cylinder valves and fittings. These must be clean and clear before you connect the torch and hoses.
And it's also a very good point. I've never hooked up an oxygen acetylene unit myself, but I've saw other people do it before. You always got to make sure that the cylinders, the valve connector, where the cylinder is, where the air comes out of the cylinder, must be clean. No oils, no contaminants, no dust, no nothing. It has to be clean.
Once everything's set up, apply a soap solution to check for gas leaks. Some problems can be solved by simply tightening the connection.
That's 100% true.
Arc welding units also need to be checked out. Inspect the frame of the generator for proper grounding. Make sure the work lead and electrode lead are properly connected.
Yeah. That's happened to numerous people that I've known over time, where they were trying to weld, but they didn't connect their ground to the fucking table or whatever. Check your work area before you freaking start, is my best advice. I know I'm sounding a little bit harsh, but please.
And don't forget to examine cables for damaged insulation or bare conductors. If left unrepaired, these can cause a severe shock.
That's very true. I was welding with a lead that wasn't properly sealed up with electrical tape, and it came undone. So there was a gap about this big in the insulation hose. Well, you can guess what happened. Whenever I went to strike the arc and touched it, it shocked me pretty bad. I mean, I've been shocked numerous times, but that was probably the worst. But the simple fix to that is, if you see damaged equipment, tell a supervisor or shop foreman, or even tell your instructor. I mean, you are obligated to have proper working equipment when you're welding. My best advice is not to just sweep it under the rug. You need to go tell someone.
The powerful ultraviolet and infrared light produced during welding operations is one of the first things people remember about welding.
It's the first thing I remember. It'll be probably the last thing that I talk about before I die, too.
Fortunately, this light can be extremely hazardous. If left unprotected, your eyes can suffer problems like the short-term discomfort of welder's flash.
I can't even begin to explain how many times I've gotten welder's flash. Only one time was it from, I did it on purpose. All the other times was accidents. It's common sense. I mean, I wear a helmet, I wear safety glasses. But, it's common sense that if you're welding in an open space, use screens to protect the others around you from your arc lights. Sorry, didn't mean to say that like that, but you gotta be protective of your environment.
More serious injuries like burns to the retina can permanently damage your eyesight and may even cause blindness. Goggles fitted with specially tinted lenses must be worn during oxy-fuel cutting, welding, and brazing.
It's very important to wear safety equipment when you're welding or brazing. People have the common misconception that oxyacetylene is basically harmless. It's not. It can still give you arc flash.
These special lenses block hazardous light and help shield your eyes from molten spatter. Arc welding produces an intense light that requires even stronger protection. Here you'll need a helmet or hand shield. These are fitted with specially designed filters which screen out harmful light rays. In addition to protecting your eyes, the design and size of helmets and hand shields will prevent the light from burning your face, neck, and ears. Don't forget that safety glasses must still be worn underneath your helmet or hand shield for complete protection.
True. Never weld without a pair of safety glasses under your helmet. It could be the worst mistake you ever make.
Make sure all your protective equipment is in good condition before you start work. If you spot any imperfections, get a replacement.
Yes, always get a replacement. If your safety equipment is defective, get a replacement.
Hazardous light can affect those around you as well. Setting up protective screens will help shield other workers from the light generated while you weld.
Okay, this part's going to get interesting. It's going to talk about fumes. So, a little background. I did have an issue with me that ended up landing me in the hospital for a couple days due to me welding galvanized steel. Basically, my lungs were so caked with mucus that, it was impossible for me to breathe. That was some scary shit, so you gotta be protective.
Hazardous fumes are a byproduct of many welding operations. Without proper ventilation, these fumes will collect and contaminate the air. You will need to protect yourself by using exhaust fans or other mechanical ventilation devices whenever you're welding with stainless steel, lead, mercury, fluorine compounds, zinc, cadmium, beryllium, and chemical cleaning compounds. It's especially important to use mechanical ventilation in rooms with less than 10,000 cubic feet of space per welder, where ceilings are lower than 16 feet, and in confined spaces where regular ventilation is blocked.
That's true. OSHA actually requires this. All this video is actually required by law.
Short periods of exposure to hazardous fumes can lead to irritation to the eyes, nose, and throat, even illnesses like metal fume fever. Repeated exposure over many years can lead to lung cancer and severe damage to the nervous system. To avoid these problems, you must maintain a healthy breathing zone. This means getting lots of air flowing around your work. If you're using screens or other barriers, leave enough space between the barrier and the floor to allow for good air movement. Sometimes, even mechanical ventilation devices aren't enough to protect you. In these situations, you'll need a respirator. But before you can wear a respirator on the job, you must be fit tested. This ensures that the respirator you're wearing is the right size for your face. It's important to remember that respirators are fitted with filters that capture hazardous fumes. Moving pieces of metal around and banging away at slag are just two of the things that can make a welding environment very noisy. If you don't take the proper precautions, you can be exposed to noise levels that can result in real.
So, this section's about noise, if you couldn't tell. I'm actually partially deaf in this ear because I wasn't protecting myself whenever I was using an angle grinder and when I was welding. Big mistake. Always wear your protection.
Real problems. Short periods of exposure to loud noise can lead to fatigue and irritability. Extended exposure can lead to partial or even total hearing loss. To guard against these hazards, you need to protect yourself with earplugs, canal caps, or earmuffs. This will reduce the noise that your ears are exposed to. If you have any questions about which hearing protection you should use, ask your supervisor. Of course, to be completely safe, there are a few other things you'll need to wear as well. Welding can produce a lot of heat. To protect your hands, you need a good, strong pair of leather gloves. Many welding gloves offer additional protection in the form of welting. Here, an extra piece of leather is sewn into the finger and palm of the glove.
Good point. I wear a pair of black stallions that go up to about here on my work shirt, which my work shirt is also flame retardant. So, with that, I'm basically not allowing sparks to come in under my sleeves and burn my arms when I'm welding.
Glove. This extra layer of leather protects the threads in the glove from getting burned by intense heat. But even with this extra protection, you need to be careful. Never hold heated metal with your gloves.
Yeah, that's just plain common sense. That's just stupid. Don't do that.
It can burn right through them. If you need to manipulate hot objects, use insulated clamps or other tools. The type of clothing you wear also plays a role in welding safely. Dress in natural fibers like cotton or wool. These are less likely to ignite than synthetic fibers. Wearing long-sleeve shirts with closable collars will protect you from hazardous light. Remember, just like the ultraviolet light from the sun, the UV light from welding operations can burn your skin.
True. That's why my face is permanently red.
Adding leather aprons and sleeves on top of what you're wearing will keep sparks from burning through your clothes. Another good idea is to wear high-top shoes. These keep sparks and molten metal away from your ankles and feet. Sparks, high temperatures, and flammable gases can all lead to fires. To combat the risk of fire, many facilities limit the areas where welding can take place. Never begin to weld unless your facility has authorized the work.
Hot work permit also is a good idea too. You have to have a hot work permit to be able to weld or cut.
This will confirm that the area you will be working in is considered safe for welding operations. Sparks are a byproduct of just about every welding operation. Preventing them from starting fires requires a concentrated effort.
Yeah. Always have a fire extinguisher around, and always clean your area before you weld.
Before welding, remove anything that can burn from the area. It's especially important not to weld around combustible materials like wood, paper, or fuel.
Yes.
These ignite easily and can quickly burst into flames if they're exposed to sparks or high temperatures. Aerosol cans should also be removed from areas where welding is taking place. These cans hold gases that are under a lot of pressure. When they're exposed to intense heat, the gases will expand. This could cause the can to explode.
Yeah. Okay, so aerosol cans. The contents inside of them are pressurized. So, like, if you expose them to high temperatures, chances are what's going to happen is that gas is going to keep going and getting larger and larger and larger until it can't fit in the container, and the container goes and busts apart. So you never want to weld around aerosol cans, even if they're empty.
If there are ignitable materials in the area that can't easily be moved, use guards or barriers to protect them from sparks and heat. Sweep up any debris that may be lying on the floor. It's best to sweep in a 35-foot radius, beginning at the spot where you're going to weld. In the event that a fire could still ignite, a trained fire watcher is required to stand by. This person should know the ins and outs of firefighting and will be ready to extinguish a fire if it breaks out.
You always have to have a fire watch if you're welding around combustible materials. You also have to keep a fire watch for at least 30 minutes after the weld.
Follow safe work practices. This way you'll avoid accidents. Always wear the appropriate protective clothing and equipment. Keep your area well ventilated. Make sure the air you breathe is safe and clean. And work to prevent fires. Remove or shield any flammable objects in the welding area. Defeating the hazards that welding presents can be easy. All you have to do is follow the rules and work safely.
And that's the video. So, to give a little bit of a recap here, I discussed light, noise, fumes, fire safety, and we discussed standard operating procedures. Please like, comment, and subscribe.